My name's Eugene Meitinger, and I threw out my intro slide because we only have 20 minutes to cover the hard parts of DAX. There's not many hard parts. It'll be fine. And I work as a business intelligence consultant. So people give me lots and lots of money to pretend that I know Power BI. I also make training courses on Power BI and other technologies. And so you'll see that reflected here because I like to use analogies a lot. And so a lot of this session today is about analogies and where do people get stuck? And what mental models do I wish I had 6 years ago? Has it been 6, 7, 8? However long Power BI has been around. DAX has been around since 2010. The mental models I wish I had. So with that, start the timer, and let's go. So if I was doing my hour-long session, I would include this slide to cover what I would cover in my hour-long session, because the learning curve on DAX is misleading. It lulls you into a false sense of security. You know, we've got this Dungeons and Dragons thing, you're frolicking through the woods, and suddenly there's a big troll that hits you. And so the woods are scalar functions. These are functions like if, or convert, or all these things that output a single value. That's what scalar, oh, come on. Why is it doing this to me? One moment, folks. Yes, okay. You just hit buttons till it works. So scalar functions input a value, output a value. Really simple. They're like mathematical functions. That's where the term scalar comes from. You multiply it by a number to scale it. And the calculated columns, those work the way that you think. If you're coming from Excel, you know how to use calculated columns. This is easy. We're frolicking through the woods. But then the troll comes out. And so the troll in this case are measures, filters, and evaluation contexts. If you can make it through those things, then it gets a lot easier, okay? And so if I was doing a 1-hour talk, we would talk about that. But I only have a third of that, so I'm not going to talk much about the technicalities at all. I'm going to talk about concepts. So why is DAX hard, right? I think the Italians say it's simple but not easy, right? So why is it not easy? Well, let's use an analogy. So I asked before, but does anyone here speak German? That's unfortunate, because I'm going to butcher your language. And if you speak Swedish or Norwegian, and I'm guessing maybe Dutch, this also works as well. In language learning, there's the idea of a cognate. Words that sound or look very similar. So, der Apfel, apple, right? So you're learning German. I learned it in high school. I remember a few words, straightforward. Das Buch, book. Right? And then you're like, oh, das Gift. I can give my friend a gift. What does gift mean? Poison. If you try to transliterate, if you try to just take words in English straight to German based on how they look, eventually it may seem like a gift, but really it's going to taste like poison. And this is the problem that I ran into when I was trying to learn DAX 6 or 7 years ago. I knew Excel, I knew SQL, I thought it was some mixed family child of the two, and I would be fine. And I was not fine. So why is that? Well, again, talking about languages, Excel whispers and cells. A2 plus 7, B4. It's like a game of bingo, right? It's all these cell references. And so if you're coming from Excel, you're used to being able to say, I want that cell, that specific one. This one is special. It has my special formula that I made myself. And no one's allowed to delete it. SQL speaks in rows, right? It's a little bit more obvious. You have to be a little bit more specific about what you're doing because you have your select clause, your from clause, your where clause. And so it's a little bit more obvious what's going on, but you're thinking in rows. And in fact, SQL Server is a row store engine. And we'll get to that more in a little bit, but the key part is it literally speaks in rows. It saves the data on disk as rows. Well, DAX shouts in columns. And if you do not anticipate this, it's going to be confusing. My Uncle Johnny, he married into the family. He's Italian, and he used to be my Sunday school teacher, right? So at Sunday school, he was, calm and controlled. But when you would go to his house, he's dropping swear words everywhere. He's moving around. He's shouting. And if you come from a different cultural background, you're like, why is he mad at me? It's like, no, that's just how he is. It's a cultural thing. So DAX shouts in columns. So what do I mean by that? Here's the problem with row store engines. So imagine SQL Server. Again, SQL Server speaks in rows. It stores the data in rows. But when you're dealing with analytics, you don't need all of that data, right? So imagine that this is Dynamics Great Plains, one of the 50 ERP solutions that Microsoft has purchased over the years and then called Dynamics, right? So maybe we're here in Europe, Dynamics Navision, whatever, right? And my boss says, Eugene, what color do people love the most? We're selling T-shirts. These are state, you don't need to worry about that here. You can imagine countries in the EU or something like that. We don't care about where they're buying them. What is everyone's favorite color, right? Well, with a row store engine, you have to grab one row, and the next row, and the next row. You have to grab every single row and all of its contents. Now, you can do some indexing to skip some rows, but you can't avoid pulling out the contents unless you have secondary non-clustered indexes, right? So inherently, a row store engine is de-optimized for analytics. You have to do additional work to make that work. Well, what if I told you we could shout in columns? We could store our data in columns, believe it or not, right? We could do some hardcore parquet and store our data in columns. Well, that's what DAX does, the Vertipack engine. And so now if I want to know people's favorite color, get quantity, done, right? I don't need to grab 50 other columns by accident. So inherently, a column store engine is out of the box optimized for analytical reporting, right? And that, again, that's part of the confusion. Is you're like, why are you shouting at me, DAX? Why are you so mad? And it's like, no, it's a different culture. It's a different optimization. But in addition to that, it compresses and encodes the data because it knows it's storing them as columns. So there's further optimizations that are available because we're shouting in columns, because we're thinking in columns. And these are things that you'll see in other places. So if you read about Parquet or Column Store or whatever, you'll see these types of patterns pop up, right? So the first one is value encoding. So I live in a small county. You can imagine a small town in the United States. And in the greater Pittsburgh area, there's probably, I think, about 2 million residents, right? In the county that I live in, I don't know, 150,000, something like that. Well, occasionally I get blood work done because I'm a diabetic, I'm a cyborg, I got a little sensor here, and I'll get an invoice. And the invoice will be like 5,233,478. That's my account number. Now, I can assure you, there are not 5,233,708 people in my county. They do not have 5,233,708 customers. They just don't. What has happened is some genius in IT said, well, we can sort out the routing easier if we just take department number and put it in front of account number, right? Because I have a different account number, depending on whether I see my primary physician or GP, as you would say here, or I get blood work, or I go see a specialist. Now, from a data storage perspective, though, we don't need to store all that data. Why should we have to have numbers that big? So one of the ways that DAX encodes the data is called value encoding. If you have a number, you can take that 5 million, put it off to the side, and then store the deltas, and you don't need as much space. Another optimization is dictionary encoding. So dictionary encoding is really simple. It's a hash map, right? So the joke I make in the United States, that probably won't make any sense here, is we have the world's most famous groundhog in Pennsylvania. His name is Punxsutawney Phil, and he can predict the weather. He comes out of his little hole, and we say, oh, well, there's going to be 6 weeks or no more weeks of snow. Don't ask how, we're a little strange in America. But he's got a really long name, Punxsutawney Phil. And you can imagine that I might have a set of groundhog facts, and in my fact table, Punxsutawney Phil happens again and again and again and again. Well, why should I need to take up 20 characters of space to store his name? Why don't I put that somewhere off to the side and put the number 1? And then when I see the number 1, I go look it up, and it's like, oh, it's Punxsutawney Phil, the world's most famous groundhog in the world's most famous state, Pennsylvania. And so that's basically what dictionary encoding is doing. When you're dealing with DAX, it says, no, everything's just numbers. Everything's just integers. And then the final important compression or encoding technique is run length encoding. And so I have an example of this, but what's going on is you sort the data. So the fewer columns you have, the easier this is to do. If you've got 50 columns, then the ones that are sorted last won't benefit from this, right? And you sort the data, and you take a look at, okay, what's my run? So generally, this is going to be, it's going to start with a column that's low in cardinality. There's not a lot of potential values, right? There's no reason to say red, 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 red. Even if we did the dictionary encoding, there's no reason to say 3, 3, 3, 3, 3, 3, 3, 3, 3, right? Instead, what we can do is we can take that run and store the length of it, right? So we can say that, okay, blue happens once, green happens twice, red happens 4 times. And so this is tremendously more performant, as you can imagine, right? If you have some value repeated 10,000 times, 10 million times, which is common in denormalized data, which is common in analytics, this saves huge amounts of space. In my experience working with DAX, for data that is cleaned up enough, so no GUIDs, minimal primary keys, no comment fields or any of that kind of stuff, I've generally seen 5 to 10x compression. And it's because of all these techniques. This is why DAX shouts in columns, because it's more performant, it takes less space, and it's better for analytics, right? And when you understand that, things make a lot more sense. Speaking of things not making sense, remember I told you, if you try to just translate or transliterate, just take the words in Excel and move them over to DAX, you're going to run into issues, right? And so here, imagine that I want to add a month to a date I already have, right? We want to say, okay, what's next month, given the transaction date? Maybe you have a situation where you charge invoices on net 30, right? Which is technically not a month, but bear with me. Well, here's how you do it in Excel. You use the eDate formula, and then you get a number, so maybe Excel isn't any better. But if you format it as a date, and sorry everyone, dumb American here, that's February 1st. But this kind of works the way that you would expect it. You're used to whispering in cells, okay, A1 plus a month is February 1st, right? Now, what happens if you try to do the same thing in DAX? Well, I don't think there's an eDate formula or function, but there is a date add function. And it's in the name. It says it adds dates, right? Like, how hard could it be? Well, it doesn't work. If you try, again, you're like, I have gotten you a gift. And they're like, don't make me drink that. I'm not drinking that gift. So what's going on here? There's a couple different issues. So the biggest one is that date add does not work on scalar values like you anticipate, okay? It works on columns. It speaks and shouts in columns. So that's the first issue, is you think that you're referring to a specific cell because you've named it, and usually that works with calculated columns. But in this case, what's going on is it's actually referring to the column name. But there's another issue that's related here that we can't get into as much as I would like in 20 minutes, but I can give you an analogy. See, it's all about context. I'm sure, like, Renato probably told me, Eugene, I'd love to attend your session, right? Oh, that's very sweet of him, right? But without changing the words and without changing the syntax, we can change the context of what he might have said. He could say, oh, I'd love to attend your session, right? Or he could say, I'd love to attend your session. Or he could say, I'd love to attend your session, right? All the same words, all the same language, all the same syntax, but the context has changed. The way that I evaluate those words has changed. And that's one of the biggest stumbling blocks when it comes to DAX, is understanding evaluation context. So the issue with DAX is that it shouts in columns, but there's some nonverbals, there's some subtleties there that you have to understand, right? And if you don't, and you won't when you first learn it, you're going to wonder, well, why, going back, why is this blank, right? And so there's 2 reasons that it's blank. The first one, like I said, is in this situation, we're referring to, it's actually probably more complicated than that, unfortunately. But first we have to understand, okay, we're referring to the specific cell, or we're referring to the column. But then also, date add doesn't just add things, it changes that evaluation context. This is scare quotes, right? This is saying, oh, let's add a month, right? So you thought you were looking at a specific date range, but let's add a month. So there's two types of evaluation contexts that you're going to run into when you're dealing with DAX. They're polar opposites, very different, and you have to understand this, and it takes a couple times to get it. So the first one is the row context. It says, it's bold, it says, look here, okay? Because normally, we're speaking in columns, but occasionally we do need to speak in rows, right? And so where that comes up is calculated columns and iterators. So the thing I showed you a picture of is called a calculated column. And we don't have time to go into that today, but the short version is that a calculated column goes row by row by row, calculates a value, and then saves it, just like it works in Excel. And so this is intuitive, but you remember at the beginning of my talk, it was right before the troll smacked you into the ground in the woods as you're frolicking along, right? Because that's intuitive, because it's limited to a row. You can refer to cells. You also will see this in something called iterators. If you've used DAX and you've used filter, or you used any of the functions that have an X on the end, like sumX or minX, I assume the X stands for extreme, I don't know, you've used an iterator. So an iterator translates from columns to rows, okay? The other context is a filter context. It's italics. It's not quite. You asked for this, but not quite that. And so what dateAdd is doing, it's common when you're using calculate, it's common when you're making measures. What dateAdd is doing is it says, oh, you put italics on this word, but I'm moving it to a different word, right? Or you wrote, I'd love to attend, but really it's, I'd love to attend. And so whatever filter the user or the code has applied, it will shift it over by however much you want, right? So this is great if you want to say, okay, what was like the month-over-month sales? You would use dateAdd along with a thing called calculate to figure out what that is, right? And so when I think of the calculate function, if you use DAX, you're going to use this all of the time. It's a bait and switch function, right? It says, you thought you were going to calculate the sum of this under this context, but not quite. It's actually this different context, right? And so if you can understand that, and you can understand that these are the two things that change the meaning of the code you're writing, even if it's identical code, that's going to help you. So, in summary, the three big things to get over the hard parts of DAX. DAX is a foreign language. If you're used to Excel, if you're used to SQL, some of the words will translate just fine. You know, like if you try to use like sum or if or something like concatenate, that all generally translates fine. You know, book is book, apfel is apple. But if you just try and copy and paste everything, or you try to just use it blindly, eventually you're going to try to give someone a gift, and they're going to keel over because you gave them a poison apple, right? So you have to be careful with that. Second thing, DAX shouts in columns, right? Everything is in columns. And to get away from that, you have to use an iterator. You have to use a row context to get away with that. And this is a big point of confusion, because we use the same syntax to refer to a column or a cell within a row context. We just refer to the name, but it really means two very different things, okay? So this is the biggest source of confusion with DAX. Finally, it's all about context, right? This is why trying to talk to your friends over text messages is so fraught, and you add all those emojis, because you're trying to bring back in context about what you're talking about. And so it's the same thing with DAX, right? The calculate function is really just an emoji if you think about it at the end of the day. But once you understand what a filter context is, what a row context is, and when they apply, DAX becomes a lot easier. So I would love some feedback. I'd love to hear how this went. This is the first time I gave this, but thank you, everyone. Thank you for attending. I'll be around for a bit.